So here we have our first bearings problem. A boat sails from a point P on a bearing of 70 degrees for 8 kilometers to a point P. Let's pause there. And let's just represent this on a diagram. So a boat sails from a point P. So where are you coming from? You're coming from a point P. Where you're coming from? Alright, coming from a point P. So you always put establish first where you're coming from. Alright, and of course, you need to put the north direction there. Alright, so you're coming from a point P. Coming from P, and a bearing of 70 degrees going to Q. So 70 degrees going to Q, 70 degrees. Where do I find 70 degrees now? Just before you reach 90, because remember 90 is, and by the way, just a moment, before, when you're doing this graph, it's always a wise idea to extend to the north a little bit. It's going to prove important to do that. Let's expand this a little bit. Alright. And alright. So now 70 degrees to Q. So we're coming from P to Q, going to Q, and 70 degrees, right? 70 degrees just before you reach 90 degrees. Is that so? Yes. Alright. Good. And now I want to put in your angle 70 degrees. A bearing, so it's always from the line coming from the north, and of course going to Q. After which now the boat then changes course and started sailing at a bearing of 120 degrees to a point R. Alright, so 120 to a point R. Alright, so you're coming, so going to R, obviously, you'll be leaving Q to go to R, right? So you have a north direction there, and you extend it. Alright, extend it to be a straight line there. So a little bit, and you're going what direction? From the north, 120 degrees. Where do I find 120? Just past the 90, right? Just past the 90. Alright, so just past the 90. And how far is it? 10 kilometers. Alright. Just past the 90, maybe somewhere about there. Alright. To a point R. So the bearing of R from Q is, we're told, 120 degrees. So you always put the angle anti-clockwise coming from the north. Coming from the north, alright? From where we're coming from. So let's do a little bit of, so before I do some geometry here, let us close the shape. I'll put in the distances. We're told that this was 8 kilometers, right? From P to Q, we're told it's 8 kilometers. We are told that from Q to R, that's 10 kilometers. Now we're asked to find the distance PR. Now PR, we ask ourselves the question, can the sine rule work? Yes or no? Let's see if we can get some angles here. So this is 70. Now, alternate angles. Remember this line here. This is north to south. Likewise, north to south. So these two lines are parallel. Hence, this angle is alternate to the 70. So this is 70. Also, angles on a straight line add to give 180. So if this is 120, then this section here would be 60 because the angles on this line should add to 180, right? So this will be 60 degrees, 70 degrees. So we want to find the length of PR. Of course, sine rule will not work because for sine rule to work, you need the length of one side and you need the angle opposite to it, which we do not have. And we can see that cosine rule will apply here. All right, what does the cosine rule says? Take one side and square it. Let's take PR. You take any side. We choose to take PR. That's the side we want to find. So remember, cosine rule begins in the same way Pythagoras theorem begins. This one side square equal to the sum of the other two sides square is 8 square plus 10 square minus 2 times the product of these very same sides. So 2 times 8 times 10 cos the angle formed by these two sides. What's the angle these two? So the 8 and the 10 meet to form. Or you want us the angle opposite to PR. And that angle is what? 130, 70 and 60. Alright? So cos 130. So we're focusing our attention on this triangle here. Right? PQR. So PR square is equal to, let me get my calculator. So 8 square, that's 64, plus 10 square, that's 100, minus 2 times 8 times 10. 2 times 8 is what? 16. So minus 160 cos 130. Close bracket. So 266.8. Let me call it 269. So this is 269 to nearest whole number. Alright, so the distance from P to R is 269 kilometers. Alright. Now we are asked to find the bearing of P from R. The bearing of P from R. So you're coming from R. So which angle do we want now? If you're coming from R, you're coming from R. The bearing of P from R. So we're coming from R. Let's do the north of R. That's the north of R, right? Let me do a little come down here. Let me just clear. So make some space. Alright, so we are coming from the north of R. So we're coming from R to P. So from the north of R to P. So which angle do we want? Let me extend this first. So we'll extend that. Alright, so that's the angle we want. Alright, the bearing of P from R. So you're coming from R, so you do the north line and come from the north line to P. Okay, you're going to P from R. So this is the angle that we want. Now how can we get this angle? So you will note that from here to here, I'll put it in green. If I put from here to here, is 180 degrees. Alright, that's a straight angle, straight line there. We know from here to here, these are different color. We know that this angle is alternate because remember this line through the Q is parallel. These lines are parallel. All the direction lines are parallel. So if this angle is 60, then this is the alternate angle. Will also be 60. Alright. So to get this angle, so we know this is 80. Well, that wouldn't help. We know this is 80. Alright. So we need now to get this angle. So because angle on a straight line had to give 180, right? So we need the angle we need this angle before we can determine all of this angle here. Alright, so let's find this angle. And of course, we can use the cosine rule. So we can use the sine rule. So let's use the sine rule. What the sine rule says, let me call this angle x. I'm going to call this, I'm going to label it x. Let me label it x. Alright? I'm going to call the angle inside there x. And the cosine rule says the sine of any angle, so if I sine x over the side opposite to it, which is what, 80, is equal to the sine of any other angle. Let me use this angle here, 130, so sine 130 over the side opposite to it, which is 269. And I can multiply, remember I want to get rid of the 80. Alright, I want to get rid of the 80. So I can multiply both sides by 80. So 80 times this side and 80 times this side. So 80 times both sides, if 80 into 81, 80 into 81. So sine x is equal to 80 times sine 130 upon 269. Let me just write that out. So 80 sine 130 equal, divide 269 equal 0.228, 3 decimal places, which means angle x will be a shift second function. So second function sine or shift, depends on the type of calculator, 0.228 equal 13 to the nearest whole number. So 13 to the nearest whole number. So x is 13 degrees. So this angle inside here is 13 degrees. Now how do we get this angle here? How do we get this angle? Remember, angles on a straight line had to give 180. So if this angle is 60 and this angle is 13, then what is this angle? This angle here will be 180 minus the 60 minus the 13 inside the triangle here. So what's 180 minus 60? What's 180 minus 60? 180 minus 60, that's 120. And 120, take away 13, that's 107. So this angle is 107. So the bearing you want is from R to P. So here to here is 180. And then this piece here now is 107. So it's 180 plus 107. So to answer the question, the bearing of P from Q will be 180 plus 107, which gives us 287 degrees. And that's the bearing of P from R.